Okay, last two examples, and this is the most algebraically heavy example, these last two. We want to do a proof. We want to show that this monster, this equation, is in fact an ellipse, which is basically just making this look like one of these. Which one? That's unclear right now. So I can't put my red X anywhere right now. I'm not really sure where it's supposed to go. So I'll just hang off on that. But then after I do that, I have to find the vertices, the foci, and the eccentricity. Eccentricity is the word eccentric means off center. And for ellipses, that tells us how much of a stretch really was there. And it's determined by the ratio of C to A. So C divided by A is the eccentricity of an ellipse. And this is not the number E. This E is standing for a variable. This is the variable for eccentricity. All right, now how do I do this? There's a lot of stuff going on here. We're going to be completing the square. So if you're thinking that, that's fantastic news. We are going to complete the square, but we have to do it twice because look, in either one of my equations, I got two squares in both of them, x minus something squared and y minus something squared. So I had to complete the square twice. So I hope it makes sense that we should organize all the x's together and all the y's together and get rid of the number. So get the number on the other side of the equal sign and get all the x's together and get all the y's together. So that's what I will do. Making sure that I'm keeping my symbols. This is minus 32x, so it remains minus 32x. And I subtract 124 on both sides. Now I'm ready to complete the square. And with these two, remember, we don't complete the square, we get rid of this 4 first. So we factor out this 4. But just with these two terms, because you really need to have tunnel vision right here. Only be focusing on this. And then focus on this. So you have to focus on these two sets independently of one another. So just with these two, I don't want this 4 here. I want it to be a 1. So I'm going to factor out a 4 from both of these terms. And that gives me this, 4 times x squared minus 8x. And I have to complete the square right here. And this y squared is already 1y squared, so I don't have to do anything there. I just have to think, well, how can I complete that square? So we're completing two squares. And notice I have to keep the balance, of course. And I'm sure you can tell me what goes here. Half of negative 8 squared. So half of negative 8 is negative 4. If I square that, I get 16. And half of this squared, half of this is 8, and 8 squared is 64. What goes over here? We'll do the blue one first. If I added 64 on the left, I definitely add 64 on the right. But this is not 16. Why not? What is underneath here? I wrote down the number 16, but I did not add 16 to the left side of the equation. I realized I wrote down 16, but I didn't add 16. I actually added 64. Why? Because even though this looks like the number 16, you see how it's in the parentheses? Everything in the parentheses is being multiplied by 4. So when I write down 16 here, what I actually added was 4 16s. And 4 times 16 is 64. If I put down a 3 here, first of all, that would be disastrous because that doesn't complete the square. But just for thinking about this, if I put down a 3, I actually added 12 to the left side because whatever's in the parentheses is being multiplied by 4. So I've completed the squares and now I factor. This factors into x minus 4 squared, y plus 8 squared. These three numbers combine to get 4, and I'm so close. But this does not look, remember my two equations, they always equal 1. So that's easy to do. I just divide both sides by 4. If I divide both sides by 4, this of course will become 1. But I have to divide everything by 4, this and this. If I divide the left by 4, those 4s cancel out. And when I divide the y part by 4, it gets divided by 4. So now, finally, now I know that this ellipse is a vertical one because the a squared, 4 is bigger than 1. It's underneath the y part. So it doesn't make any sense. I mean, I could do this now, but who cares? Now I know that I'm dealing with the vertical one. And usually the stronger one comes first. So addition is commutative. Thank goodness I can switch them around. All right, and then this was also asking me to find the vertices, the foci, and the eccentricity. So the vertices are A away from the center. The foci are C away from the center. So we got to find A, we got to find C. Well, the center is 4, -8. Remember, the x value would be 4, the y value would be -8. A is 2, and B is 1. So the vertices they're always A away from the center. So I start with 4, -8, and I just add A to this y value and subtract A from this y value. So I get 4, -6 and 4, -10. Adding the A value to the y and then subtracting A from the y. The foci are C away from the center, and I don't know what C is. But remember, A squared equals B squared plus C squared. And I know A and B. I know A is 2 and B is 1, so A squared is 4, B squared is 1. And I can use that to find C. C is radical 3. So the foci are radical 3 away from the center. Here's the center, 4, -8. I would add rad 3 to -8 and subtract rad 3 from -8. Or in other words, just this, -8 plus or minus rad 3. And finally, how eccentric is this ellipse? C divided by A. C is rad 3, A is 2, so the eccentricity is just rad 3 over 2. That was a big one. I expect some questions on these. These are time consuming, so I think you have one on your homework, maybe two. But we do have to do them. Otherwise, it's going to take us several hours just to finish this test. Let's do one more. All right, this is the same as example 5. With slightly less work to do, we just have to find the eccentricity, not the vertices or the foci. So here is another one. You should definitely pause the video and see if how much you can do this on your own. You want to group the x's together and the y's together and get this number away. So don't forget, this is minus 12x. So when you rearrange it, you should still have minus 12x. And now I would separate the terms. I'm really just focusing on these two and focusing on these two independent of each other. So I don't want this 3 here. I want it to be a 1. So I'm going to factor out a 3 from both of these. I don't want this 5 here. I want a 1. So I'm going to factor out a 5 from both of these. And I get this. And now to complete the square, I put a 4 here and a 9 here, because half of 6 is 3. 3 squared is 9. But what did I really add to the left side? I didn't add 4. I added 3 4s. So that's 12. So I have to add 12 on the other side to keep the balance. And I didn't add 9 here. I added 5 9s. So I added 45. So I had to keep the balance. And now the hard part is over. Now we factor this. This is 3 times x minus 2 squared, 5 times y plus 3 squared. All three of these add up to 15. And now divide by 15. So 15 divided by 15 will be 1. What's this going to change to? The 5 will cancel out with the 15, leaving me with a 3 underneath here. Here, the 3 will cancel out with the 15, leaving me with a 5 down here. So now I can see that this is a horizontal ellipse because the major axis is the a squared is the 5, which is underneath the x. So that means it went rad 5 to the right, rad 5 to the left. And I have to find the eccentricity. So I have to find C, unfortunately. I know that a squared is 5, so a is rad 5. B is rad 3. And I use this. So a squared, well, a squared is 5. B squared is 3. Solve for C. C is rad 2. The eccentricity is C divided by A, so rad 2 divided by rad 5. And then to multiply both sides by rad 5 to rationalize the denominator, and I get rad 10 over rad 5. Whew. So there's a lot of algebra here. You're gonna be amazing at algebra. So, but it involves some work and some practice. And this one was a horizontal one, so we can blot out the vertical one. All right, good luck, everybody, and get cracking on the homework. My Math Lab, I think the My Math Lab assignment for ellipses had about 15 questions, and just try to do around 6 or 7 a day, and you should be good.